on this frequency table you see 300 meals ordered over the several weeks, and there are 10 different main courses. The problem here is there any significant differences in terms of the preference in the selection of main courses at the hotel? Now I just put here observed values, those are the observed numbers. Then I'm going to put the next column expected. Now the expected values, if there's 10 different menus are perfectly equally distributed, then that will be 30 order for each one. So in this case, this is the expected value, theoretical frequencies if the distribution is perfectly equally distributed. So I'm going to take the sum of these numbers. So auto sum and hit OK. So expected value always should be equal to observed value. That means we are on the right track. If there is something wrong, if these two are not equal, that means there is something wrong. So the next step, we need to do a process for a chi-square distribution. Now again, there is always a test value and critical value. For chi-square, in order to find the critical value for one way, there is only one dimension here, there is only one factor or one dimension here. So degree of freedom equals number of category or number of group minus 1, which is 10 minus 1 here, which is equal 9. Now in order to find the critical value, we go to function and chi-square, C-H-I-I-N-V, chi-square. C-H-I-I-N-V, chi-square, C-H-I-I-N-V. Okay, hit OK. Now the probability I'm looking for 0.01 and degree of freedom 9. So hit OK. So 21,666, 2167. Now we need to find the test value to compare with critical value in order to make a decision. And the formula for the test value is observed value minus expected value, then square divided by E, then take the total. So let's do this here. First column here, O minus E, O minus E. So I'm going to write a simple formula, observed value, which is B2 minus C2, and then now I can copy the formula here. I can copy the formula. So the next step is O minus E square. Let me put this in the bold. O minus E square. So another simple formula, D2 square. D2 square. Hit enter. And I want to copy this to the end. Okay, another step, O minus E square divided by, so O minus E square, I'm going to copy this, O minus E square divided by E. Obviously it should be a parenthesis for numerator. Okay, so this time then this equals O minus E square divided by expected value E, and then hit enter. And I need to copy this to the end, and 2 decimals would be enough. Then based on the formula, I need to take the total of this. Sigma stands for the total, so auto sum will give me the total. So 3127. Now the test value is 3127. Let me put here the test value 3127. If you compare this test value with the critical value, you can see the test value is greater than the critical value, which tells me H1 accept and H0 reject. So with 99% confidence, I can say there is a difference between the preference in selection of the main courses. Now the next step will be to discuss where the difference comes from. If you compare the observed values, or let's take a percentages here, here, I'm going to bold this, the percentages, observed percentages, so 22 divided by 300, and let's do it for every, copy this, I put percentages this way. So you can see the beef kofta with saffron yogurt and grilled fish with artichoke caponata and beef risotto with pappardelle and mint. Those are the most preferred, and the least preferred is chicken in red wine vinegar. So most of the differences comes from these 4 different dishes.